Okay, it turns out if you take the nth root of a times b, then as long as a and b are real numbers, then the nth root of a times b is the nth root of a times the nth root of b. And if you just look at regular numbers in place of a and b, you can see that this is true. How about the square root of 4 times 9? What's the square root of 4 times 9? Square root of 36, right, which is 6. And if you break up this, the square root of 4 times 9 is the square root of 4 times the square root of 9, don't you still get 6? Because the square root of 4 is 2, and the square root of 9 is 3. You still get 6. So that doesn't prove it, but at least makes it believable in your mind, hopefully, that you can split up, in general, you can split up the radicand for the nth root over multiplication in general. Okay? Multiplication splits up the root. And it works, by the way, for division as well. If you take the nth root of a divided by b, the nth root of a divided by b, that's the nth root of a divided by the nth root of b. The nth root splits up over division. Do you think it works for addition and subtraction? It doesn't. It doesn't. So just very quickly, the nth root of a plus b does not equal, in general, the nth root of a plus the nth root of b. And it doesn't work for subtraction either, so we could put a plus or minus there. Not equal, okay? So don't try to do that. That'll be the dark side, you know, the temptation. It's tempting to do that, but it doesn't work in general. In part A, simplify the square root of 361 over 16. So that last property I wrote down involving the quotient, a square root, or really an nth root of a quotient, basically says the nth root of a quotient is the quotient of the nth roots. In this case, n is 2. It's a square root. When it's 2, you don't see it written down, do you? So how does this break up? The square root of 361 over 16 breaks up to be what? Square root of 361 over square root of 16. And so that's helpful because then you can just individually take the square root of the numerator and the square root of the denominator. I can do the denominator without a lot of thought. What's the square root of 16? 4. So I know I get 4 on the bottom. Does anybody know the square root of 361?
19.
It does turn out to be 19. So 19/4. Let's take a time out here and I'll show you how to work your calculator. So on your calculator, if you want to take a square root, if you have a calculator like a TI 80 something or even a TI 30 something, if you want to take the square root of 361, just go second function, the x squared button. 361, enter. If you want to take like a fifth root, then I think there's a way to actually do it on the calculator now. But the old way of doing it, and it'll be relevant in this class too, let's say you want to take the fifth root of 32, then you could just type in 32, and instead of taking the fifth root, you can bring it to the 1/5 power. That's the same thing. The 1/5 power is the same thing as the fifth root. Anybody remember that? So 1/5 is 0.2, so you could just raise it to the 0.2 power. That would be a quick way of doing it. So that's the same thing as the fifth root of 32. Or if you wanted, if you didn't have a nice fraction like 1/5, you could go 32. This button right here, I call it the caret button, will raise 32 to some power. Then you could type in 1 divided by 5. On some calculators, you'll need to put parentheses around the 1 divided by 5. If it doesn't have math notation and doesn't raise it up like that, you'll have to put parentheses around it. So anyway, that's how you get your calculator to do it. What if it's not a perfect fifth power? Let's see, what if you try to take like 33, the fifth power of 33, then won't it just be a little bit bigger than 2? Well, just, yeah, you could go 33 to the 0.2, 1/5 is 0.2. And then it should be 2 point something, right? Yeah. So you can approximate nth roots. N was 5 in this case. You can approximate nth roots using your calculator. So it's pretty handy. Okay. Okay, what about part B? In part B, we're taking the opposite of the square root of 81. So what do you think you do first? Well, what's the square root of 81? 9, and then, whoops, whoa, that was weird. Okay. So the square root of 81 is 9, and then you just, the negative just comes along for the ride, so negative 9. The opposite of the square root of 81 is the opposite of 9, or negative 9. Okay, but what? Okay, let's just change it. Let's put the negative on the inside. What's the square root of negative 81? Well, let's go back to the definition. Is there a real number that I can square and get negative 81? No. So the square root of negative 81 is not a real number. So all we know about it up to this point in this class is real numbers. So we'll just say it's undefined. So it's undefined, meaning there's no real number that you can, there's no real c that you can take c, square it, and get negative 81. There's no real number c that satisfies this. That statement. But we'll say undefined. By the end of this chapter, it will be defined. It'll actually be 9i, but we won't worry about that yet. Okay, let's try part D, the square root of 16x squared.
4x.
Yeah, but there's a problem when we say 4x. What if x is a negative number? Are you allowed to get a negative number popping out of a square root or an even indexed root? No. So what do you got to slap around the 4x?
Absolute value.
Yeah, so the answer is technically the absolute value of 4x, and that may be new to you. And that's based on the above definition, right? Now, under tips, remember how I gave you some tips? There's another tip I could tell you about. So the nth root breaks up over multiplication. So does absolute value. So, okay, so if this is tip 1, tip 2, tip 3 is telling you what not to do. Tip 4, it turns out that the absolute value of A times B is equal to the absolute value of A times the absolute value of B. And that works for division also, doesn't work for addition and subtraction. So what's another way we could write the absolute value of 4 times x? Yeah, the operation here is multiplication, so we could rewrite this as the absolute value of 4 times the absolute value of x, and then Max, you were going to add something. What was it? Yeah, because the absolute value of 4 is just 4, so 4 times the absolute value of x.